combinations of hardware and software can make possible. It's it's one of the few times in the IT industry where this thing, sorry, where hardware and software today can match up to the expectations and be combined together to deliver the great experience that the IoT can deliver, taking benefit of the capability of the hardware as well as the versatility of the software. So this is the agenda for today. What is IoT really? And next we will look at one of the devices for doing IoT or Internet of Things, which is called Arduino. Um, then we will get deeper into adding the sensor and making Arduino more useful for everybody. And finally, we will get all that data to the cloud. So these are the topics that we will be covering today. The presenters for the day include myself, Abhishek, and the other presenter with me will be Vic, and many of you would have probably heard me before. And if you've not heard of Vic, he basically is he was an MVP and is currently working on various IoT projects in the healthcare domain. So let's move on. So to understand IoT, there are different things people have said about IoT. So we said, why don't we actually ask the developers in terms of what IoT is for them? And so Telerik instituted a survey, which was of about over 700 people worldwide. This report is available on blogs.telric.com. Maybe I can show you that link once we get there. But really, the survey found some very interesting facts, some of them which you may be familiar with. So the first, obviously, is IoT is confusing to people. It's a lot of things to lots of people. So we have to figure out what it means to each one of us. And that is going to be extremely important. Now, it is an exciting space for sure. Everybody wants to do something about IoT. It's the next thing to World Wide Web, but um, how do we prepare for it? What's really working now? Um, well, is there money to be made in Internet of Things as much it is hyped? All the consulting firms are going berserk over it, predicting multiple things to happen with this. But is it really going to make money for players in the ecosystem? In terms of development platform and languages, Android and Java seem to be currently the favorite amongst the people whom we have interviewed. And amongst the challenges, people have identified the security in IoT and privacy as top of their concerns. So these are some of the findings. Most of them may not be very, very startling for you, but notice the challenges, security and privacy, and focus on the fact that both of them are best delivered by software. So as much as hardware is involved, remember the beauty and the challenges still exist that software can beautifully solve. So I took a quick definition from the web, and it was very simple, and that's pretty much what I liked about it. As I said, it's different things to different people, but to me, and this line says it very, very simply: devices that connect to one another and interact using the internet. It's a simple statement, may not be fully accurate, but simple enough to say what things are. So these things are these devices, and these devices now don't only mean computers. They don't only even mean phones or mobile phones that we are holding today, but devices could be much, much smaller than them. Some of the more widely known Internet of Things devices include a Nest product that you may have heard of, which probably is not there in India. In India, you may have heard of Fitbit, which is a wearable people use for walking around and tracking their exercise patterns, their sleeping patterns, and things like those. We even have an Indian startup who's built a wearable called Goki, which was in the news in the past. And there are many more, and there are plenty more, in fact, that people are working on. Now, just to expand the horizon, is Chromecast a IoT device? Yeah, why not? It's a small enough device. It uses internet to interact with each other. So yeah, it is also an IoT device. Um, is a smartwatch an IoT device? Sure, fits the same definition. It connects to one another and interacts using the internet. Of course, yes. And I'm using internet in a slightly loose terms, and I don't only mean HTTP and World Wide Web, but internet is anything which is connectivity to the global network. That connectivity could come through HTTP, it could come through other protocols that we will shortly see. All right, and of course, in India, we've been hearing a lot about smart cities. Our Prime Minister, Mr. Narendra Modi, has talked about it a lot. I'm pretty sure different organizations are working day in and day out to figure out the details. But in the future, we are likely to see a lot of traction in IoT space coming from healthcare, smart cities, and automotive industries. It does not mean that these are the only areas which will be active. It only means that these are the areas in the future that may see a lot of traction. So today, what we are also seeing a lot of traction is in consumer space. When I talked about the wearables, when I talked about Apple Watch or Pebble Watch or Chromecast, those are devices that are in the consumer space. So you can think of them as a collection, and to think of them even in a more specialized way, you can think of devices falling into 2 to 3 categories. The first is the macro devices, which include computers, laptops, tablets to a degree as well. They sit in between. So those are the devices with a lot of capabilities, a lot of processing power, and a lot of hardware thrown at it. The second device category could be micro devices. And these micro devices you can think of simply as mobile phones, um, which are pretty much not as capable of the computers. They may not have the real estate, not the processing power, but they're getting there and they're in that little space. And then there are those nano devices, and I'm just using to highlight the categories. The nano devices would include very simple microcontrollers, single board PCs like Raspberry. So all of those things fall under the third category. So remember, 3 kinds of devices just to categorize it further. Now, if you're all going to work in IoT, how do you actually work in this space? So these are the 3 things that you need to think about when you're working with IoT. The first is the idea phase, which is where you actually think of a problem to solve. And how is that problem going to be solved with the combination of hardware and software that we've been talking about? The second is breadboarding or prototyping. This is the phase that we are going to concentrate on the most today. So this is where you actually put your idea to test and to the metal, which is check if this thing actually works or is feasible, is ready for, or even can be translated into reality for everybody. The third phase, which we are not going to talk about, is once you have refined your schematics, you've figured out this is the way that I want to go forth. You've done your breadboarding or prototyping, you get into manufacturing of the devices. So this is the phase that we are not going to talk about. There is a lot that goes on from prototyping to manufacturing phase. We are not going to talk about it. In fact, the illustration at the bottom I've simply taken from website called Seed Studio. Sorry, I should have given attribution. So Seed Studio, I've just taken their mast actually. They clearly talk about going from Bay Area to Shenzhen, which is in China, a manufacturing hub for IoT devices. So the manufacturing aspect takes this prototype that you've developed using breadboards to actual finished devices, and there's a lot that is required in that phase. Today we are only going to be focusing on breadboarding. We've talked about some of the top segments today and the ones that are going to come in future. They include things like smart homes, wearables, sports and fitness devices, automotive, logistics, and healthcare. So we'll be going about uh, shortly and exploring how do we do things with them. So we have a lot of devices and protocols that are there. So I've just put some down, and this is in no way even close to, I would say, uh, close to what number of devices that exist today. So we have Arduino, we have Raspberry Pi, we have Intel's Galileo Edison, we have Tesla, we have Spark IO, we have Beagle boards, and you name it. There are so many that it's just not possible. They again have different capabilities. They're good for different things. The ones that we are actually going to be concentrating on today include the Arduino. So we will probably be focusing on the Arduino a little more. Sorry about that. Um, and then we will probably, in the second half, also take a look at the Intel Galileo or Edison. But today, mostly we'll be focusing on Arduino. It is in no way being comprehensive, but this is pretty much a quick start. So we're not going to wait too much and lose focus. Amongst the communication protocols that exist in the devices because of the limited capability, there are again, a lot of communication protocols that exist in this space. HTTP that we are all very, very familiar with. There are a lot of wireless protocols available in the market, XP devices, Zigbee, there is Bluetooth, low energy, there is RFID. So all of them come with their specific communication protocols and hardware. And then there are certain specific communication, I would say, languages that are also being developed that are even more lightweight than the current HTTP or HTML-based communication. And this would include probably things like MQTT. So while we are again, this was the idea of this slide was to just show you what exists today. The one that we'll be focusing on today is simple HTTP, the simplest to get started with, obviously. And then we'll be using the Arduino board at the maximum today. Okay, so enough talk. Let's actually quickly get into understanding what things are. Um, Now, this is the board that we are going to be talking more about today. This is an Arduino board. An Arduino board is made as an open source hardware. The schematics, the components that are required to be made, these are all very public in nature. So apart from the core Arduino that was designed, there are a lot of different spin-offs from this Arduino board. A lot of them, there is NetDuino for .NET guys out there. And Arduino itself comes in a lot of flavors. There is Arduino Yun. The one that we are going to see today is Arduino Uno. And the specific device that we have available today is called the Arduino Uno Release 3. These are pre-composed, and if you think about it very simply, these are pre-composed microcontrollers which have standard hardware included in them. So this is what you see on the screen is the Arduino Uno, and I will kind of bring this to light in a few seconds again. The simple thing is it runs the microcontroller that is used there is the simply the Atmega 328. So if you notice the little black thing in the center here, this is the Atmega 328. This is the brain or the heart of this whole device. There is operating voltage of 5 volts, and you can power this device using these two options. The one on the top is a simple USB, and the one at the bottom is a power that you can supply externally. It's a round pin and things like those, the simple ones that we are used to. There are digital I/O pins, 14 of them. Now, if you notice at the top of the screen, right here, you will notice these 14 pins, which are numbered from 0, 1, 2, 3. So these are the pins that give out the digital output, which means they can only output 0 or 1. So if it's working on 5 volts, it's either a 5 volts or not a 5 volts. Most of our devices today work, especially in the semiconductor industry, today are digital devices. So we'll probably be using quite a bit of these devices as we go forth. However, they also have their limitations. They're slightly harder to process, but then we have a lot more devices and capabilities in our machines these days. Apart from these 14 outputs, there is also the 6 analog input pins. So if you notice at the bottom here, these are the output pins, which are the analog, they're the analog pins. You can notice that they've talked about the DC current per IO pin being about 40 milliamperes. And we're talking about all of this because as you start putting sensors in, each of them will have their own hardware requirements. They will work differently and so on and so forth. So we have to be aware of what is possible. So if a device is drawing more than 40 milliamperes of current or requires more than 40 milliamperes of current, we have to be doubly cautious whether we want to power it directly from Arduino or do we want an external power source for it. Also notice we've talked about the device running on 5 volts. So there is actually a port which is right here, which provides 5 volts if you notice, and it's pretty it is slightly more difficult, but I've highlighted it again. Um, if you notice, it says 5 volts. So this is the port that would be giving out the 5 volt out. On the left of this, you will notice a 3.3 volts. So actually this board can give out 3.3 volts as well. And then on the right of it, there are about 2 ground ports as well. So you can use them for grounding your electronic devices as well. The memory in this device is a mere 32 KB. So it's a simple device. It doesn't do too much. It's a simple microcontroller essentially. So it's not even a processor, full-fledged processor. So it has limited memory, but 32 KB is good enough. And as we move forward, there is a lot of movement towards improving the memory so that it can host um, major programs or larger programs. All right, so this is pretty much it. A small thing that you will see. The reason why I'm showing this on the sketch right now or on the diagram is so that when I switch on the camera, it may not be as visible. But let's take a look. In the middle, there are two little TX and RX buttons. I've just highlighted them. So if you notice, these are two LEDs labeled TX and RX. They will start highlighting or blinking when there is a transmit going out from Arduino or when Arduino is receiving some data from any of the pins. Also, there is a simple power LED which is right here. You will notice this is the one that would indicate if it is powered or not. And finally, there is one that we are going to actually use today, and that is pin number 13 for our first demonstration as we go through. So notice next to pin number 13, there is another small LED. Now this LED is connected to pin 13. So whenever we give any input or output to pin 13, we can actually see that come live in this LED, and we'll actually be using this for our first demonstration today. You will notice a little more or a lot more hardware components. There are transistors, there are resistors, there are capacitors, a bunch of those things. Those serve to actually make all these components work together. Now, in your device, you may not need all of them, or in your project, you may not need all of them. But as we talked about, this is simply a prototyping board. When you're actually going to take it to the manufacturing, you don't have to use this full board as is. What you do need to use is the Atmega 328 processor, or the controller, microcontroller, which is the heart, and then you can choose specific devices. But for today, let's assume this is the one that we'll be working with. And the final thing that probably is a small addition is this reset button. When things go bad, this is the result. You just can click on it. So how does Arduino work from a software perspective? It is simply programmed in C. It does not even have concept of classes, so to say. It's pretty much a functional language, and programs, and I think that's got hidden, so sorry about that. Programs written in C in Arduino have a specific terminology. They're called sketches. So sketches are what we'll be authoring today, but essentially they're nothing but programs in C. The way we are going to be writing those sketches are going to be using Arduino IDE. So Arduino comes with its own IDE, and the reason they need their own IDE is because those sketches that we build have to be uploaded into the system or uploaded on the Arduino, and the IDE provides the capabilities of uploading them to Arduino directly. Now, in addition, there is also a serial monitor that is provided in the IDE to monitor the output from the Arduino Uno. So that's something that is also useful, and we'll be using that quite a bit today as well. So Arduino IDE comes with these things and a few more. We'll just see that in a second. So this is pretty much what we have. It is a simple, it's a very, very simple system, and we will see. But remember, microcontroller only has, or Arduino programming language essentially has only two constructs available. The first is the setup construct, and the second is the loop construct. So the setup is the one that is run once, and then it is all the way the loop that is run. So here are the here are the constructs from Sketch. The first one is a setup, and the other one is a loop. So these are the only two constructs that you will see. Um, some other specific things to Arduino include the pin mode. So you saw various pins that were there, the digital and the analogs. So either they can be used for input or they can be used for output. We will see input or output, and that is what the pin mode governs. A digital write is when you're going to actually write to a specific port, and to this digital port, that is, and what are you going to write to that digital port. So that's a digital write. There is a delay, so you can introduce a delay. The delay is specified in milliseconds. You can say a milliseconds delay of X, Y, or Z, so whatever it is. So that's another construct. Some other ones, simpler ones, are include print line, write line, and other C constructs that you may be familiar with. Now, another important thing that Arduino has is a concept of libraries. A lot of devices that are built today have their input and outputs which are digital. And to support those digital outputs, because they may be outputting just zeros and ones, and to make sense of those zeros and ones, and they may have their own custom separators, they may have their custom headers and all of that. To make sense of that data simply, I mean, and for programming ease essentially, we have libraries that have been developed for these sensors, and some more libraries as well. One of my favorites is the one that is called Necroleptic, and that puts the whole Arduino into a deep sleep. And that actually helps conserve battery. While it has nothing to do with any of the sensors, it is also a very interesting and powerful library. So libraries are another fact of life in the Arduino world. Okay, so with that, I think we are primed for moving forth and actually taking a look at the device and actually seeing the first Blinky. So the Blinky is the Hello World, I would say, equivalent of the of the IoT world. So let's try and blink the device. Okay, so give me a second as I switch over to the Arduino board and actually bring up the camera as well. In the meantime, for the small time that it's going to take for me to switch, in case you have any questions, please feel free to put them in as well. We'll be taking those questions as well. So at the end, or if it appears correct at this time, we can take that as well. All right, so I'm just going to take a second to switch this over. Give me a second. Okay, so we have the sketch available, and this is the simple Arduino IDE that we were talking about. Now, if you notice, it is pretty simple. As I mentioned, the first button verifies whatever you've written. So if we say, okay, it is there, so it is there. And then we say, okay, upload the sketch. So it will send data to Arduino. There is a serial monitor available to monitor the output from Arduino. You can actually even send input into the serial from the serial port. And if you notice, there are some other things like tools and which will have all of these other things. So you will notice I can select the board that I'm going to work with from the board's menu. There is Uno, and then you actually today can add many more. I have selected Uno already. There is also the port number that you need to specify. Since our Arduino is not yet connected, this is not highlighted, but this will shortly. And then you have the options of managing libraries and so on and so forth. Simple stuff. Notice just the two constructs that I talked about, which is setup and loop. All right, so probably time to now show you the device. Let me see if the camera has come on. Well, it is trying to. All right, so let me bring this over. Oops, it went away. Okay. All right, so the camera is slightly shy. It doesn't want to come over to that screen. I'm trying to see if I can get it over. All right, here we go. Sorry, this is, and it's switched over to a photo. One second. But in the meantime, please feel free to put your questions in. Okay, so some success, I think. Let me see if you can see the Arduino board now. All right, it is visible. So this is the simple Arduino board that we've talked about, and let me bring it a little closer for you to see. Uh, all right. So, or we've already talked about all the schematics, all the pins, which are the digital pins, are right here, as you can see. I'm pointing to them. This was the simple board. Sorry, this was the Atmega heart of it, the controller. This is the power section, which has all the different ports. There is, if you notice the two ground ports that I talked about, there is 5 volts, 3 volts, and so on and so forth. These are the analog pins at the same time. This is the power which we would connect if we were using USB, sorry, if we were using an external power. And the USB currently is what we are using, and this is going to be connected through the USB that I have, and I'm going to connect it with my computer right now. Okay, so let me plug it in. So it should just come on. All right, I think you can now see the board powered up. Here is the light, the LED that says it's on, and then there is the rest which is currently not active. So there is TX, RX, and all of those are currently switched off. Okay, let us try and see if I can do something here. So, all right, so here's the sketch. Uh, we have just, compiled it, and it is an empty sketch. There is nothing in this. How about we go and look at the port? So remember, the port was not highlighted. Right now it's connected via COM4. So that's what it's showing. It's connected via COM4. The next thing that you want to do is maybe upload an empty sketch. So you will notice it is saying compiling, and now it is uploaded. Well, the sketch doesn't do much. So sorry, you won't see much in terms of what it is supposed to do. But we can start to change that. Let's go and actually took and take an example of the simplest one, which we call as the blinky. So let's open this sketch and see uh, or what we can do to make it extremely simple. Or I can probably just simply author or simply type out this one. So the first thing in the setup is you want to put the pin. I mentioned it has the power which we are going to work with, which you saw being connected already. So it is powered on. The next thing is the pin 13, which is slightly exceptional because it has an LED associated with it. So whenever it's communicating, or you can actually play with port 13. So that's what I'm going to do. I'm going to say pin mode 13, and I'm going to set it at, I'm going to set it at output. So in the setup, all I have done is I have made the pin 13 as active and set it to the output port. Now, what do I want to do in the loop? What I want to do in the loop is to say, do a digital write. Do a digital write where? So go to 13. And remember, this was a digital port. So this would be doing a high here. So digital write 13 is a high. And then what we do, so when we say high, all it means is send the 5-volt signal there. And when it does send that signal there, the LED should light up. The next is delay. So we are going to introduce a delay of, let's say, 1 second or 1 millisecond. What this will do is it will keep the light on. So let's go ahead and do a little digital write again. And in this time, what we are going to do is we are going to change this from high to low, which means the power will go down from 5 volts to 0 volts. And then again, introduce a delay. So this will be a delay of 1 second. So that would again be moving it from high and low, and that's what would cause the blinking. All right, let's upload this sketch. So I've just pressed on upload. What it's going to do is it's going to first compile this. Um, give me a second. It's asking me to save it, which I just did. And okay, so watch what it says. It says expected before this token. What did we do wrong? Let's see. There is setup, there is pin mode, there is loop, and we didn't close the delay. Sorry about that. So great compile support. Okay, let's compile it again. And once it's done compiling, it will then be moving it into the to Arduino. Okay, uploading, and you can see information about it being displayed. You can see what was there, how much it compiled into, and then where it sent it over. So all this is in this console window. So it clearly says the sketch uses 1,000 bytes, so it's about 1 KB of program that has been compiled into, and it says maximum is 32 KB that you can send over. So this is what it is doing. Now I will switch over to the camera so that you can see that this is actually blinking at this time. So let the camera come into focus. Okay, it's still out of zoom, so I'm going to bring this closer. And notice the LED, this one specifically, the one that you see here, go on and off for 1 second each. So this is the simple Blinky where we're sending instructions to the microcontroller saying on port 13, blink it on, blink it off. Now this was the simplest that anybody does. It is the hello world of the IoT world. Now, let us actually make this more meaningful, and why not include something more enterprising? Let's actually make it more useful by adding a sensor to it. So here is a sensor. Um, so this is a temperature sensor. It's a very simple sensor. It's called DHT11, and you keep coming across these very hardware sounding numbers. You always wondered why televisions have those long numbers. Sensors are no different. And I don't know why this 11, why it's 12. Maybe there's a reason. I just don't know. So this is the sensor we are going to use. It's a simple digital temperature and humidity sensor. So what this means is it is going to actually give you temperature and humidity, and it's going to do that in a digital fashion. Now, below this is a hardware schematic of how to connect it with the Arduino. So it clearly says the one on the left-hand side. So if I place the sensor faced up, um, sorry, on the left here is the one port that should be connected to the power, which is the 5 volts. If you notice, this gets connected to the 5 volts at the bottom. The ground is connected with the extreme right, which is here, and the data is coming to through the second pin, which is right here. Okay, and you notice the third pin is actually empty, and this sensor is extremely useful because it just gives you data from a single port, which is this one. So why don't we connect it into our Arduino and get on from there. So the simpler way would have been to show you a breadboard, but I tried to make it even more simpler by not even having a breadboard, which would I thought would have made it even more complicated, more devices to bring in. So this is that sensor that we just talked about. Not too much, as you can see. So let me bring it okay into focus. Okay, you can see the sensor. And what I have done is I have these wires connected to the pins that we were talking about. So there is the left pin, which was going to go into 5 volts. This is the one that is actually going to send us all the data. And finally, we have the last pin, which is supposed to be going into the ground. All right, so why don't we connect it? I know it's extremely tiny for you to see, but believe me, I'm trying to try and connect it to the right ports. So the first one was going to go into 5 volts, and you're going to go and do a lot of this. Obviously, when I said in the beginning that it is going to be a prototyping, now you know what it means. You can't have a finished product go to market with wires like these. So all we are ultimately ending up doing is connecting this um, to this controller. But then when you're actually going to take this to production, you can actually figure out a better way of doing this. So what I've done out, and I'm checking is if what port do I connect the data to. So the data I'm connecting to port number 5. This is going to be an important one for us. So what I'm going to do is I'm just going to leave this sensor out here. So leave it like this. Now you know that the sensor is connected, and that's the schematic that we have done. What we're going to do is go back into Arduino. Let me go back and bring that screen up. All right, good. So now you know what we have to do is to actually author uh, a new sketch that can take advantage of the sensor data that I have. Now, what I have done is I have already prepared this previously in interest of time. Uh, I will just close this sketch. It is no more relevant. We've moved beyond. And here is what we are going to be doing in this sketch here. So, well, here is, it's not a very long one. um, I mentioned using the libraries. So notice this is what I have done. If those of you um, who work with C before, and I believe most of us would have. This is a simple include of the library. So this is the pin that we are connected to. So we actually connected it to pin number 5. We're defining it to be of DHT11. And this library, if you're wondering where this header file was authored, it was provided by the manufacturer himself. Really, the use of this is to make and give us simple programming constructs that would make use of this sensor possible. Of course, you can go down to reading the bits and bytes, because ultimately that's what it's outputting. But then you'll have to figure out even more, go through the data sheet and figure out the way it is sending the data out, or use these libraries. And there are many such libraries available in the community. So all right, so the first one we are going to do is the first thing in the setup. We are going to say use the serial port. So our USB is going to double up, or going to use the serial, or it's going to be the serial, and the communication is going to happen at 9600 baud rate. Now from there, we are instructing the DHT, which is the sensor, to actually begin working. And that is it, the setup that ends. The loop that that we've seen here is the one construct where we're going to take advantage of. Now the loop is which will keep running continuously. It has a delay of 15,000 milliseconds, which means there's going to be a read every 15 seconds. And then DHT is going to read the humidity, and DHT is going to read the temperature. Now, these functions of DHT are made available through the library, and once we have read it, it's pretty simple. We're going to print it out, which is serial.print, which is the humidity and temperature with these text. We're going to put it out so that we can actually observe this. Now, this is going to be put out to the serial port, and any application that's actually listening to this serial will receive this information. So why don't we actually upload this sketch? Upload. It's first going to compile this, and hopefully there should be no errors, and upload it onto the system. Give it a second. And we are done. So it is done uploading, and it should be now working. Now, as I said, well, nothing spectacular happened here, you must be wondering. But that's where the serial port comes in. So, or the serial monitor comes in. I can click on this serial monitor. I'm going to bring that in. So that's your serial monitor. Notice sometimes the baud rates are different. So you can choose amongst all of these different baud rates. In about 15 seconds, whenever that happens, you should have the temperature reading. So here we go. You can see we have a humidity currently humidity where I'm sitting in the office of 71% and a temperature of 30 degrees Celsius. Okay, second reading coming through, it's 63, so the first one probably wasn't that accurate. And this is how any microcontroller works. Till the time the serial monitor is visible, it will keep getting any data that is there, and the job of the microcontroller is to just keep putting this out. All right, so it'll keep putting this out, and you can actually keep watching this. It'll keep doing this forever. This is what the loop was for. So it'll just keep looping. Now you know what microcontrollers do, and we talked about them being not that smart. So that's when the loop becomes important, and this is what they end up doing. Now, I've made an assertion that anybody who's actually listening to these sports would be actually getting this data for them or with them. So why don't I actually take this data that is being put out and actually put it to test or try and read it from one of the systems. So what I've done is at this time I have a simple program available written in Node that can actually read this data and take it further. And just to show you what I'm going to do, this is what I'm going to do, which is I'm going to take this data and send it over to the cloud using my computer. It's not very uh, realistic because you've got this awesome small device and you're connecting it to a big computer, but then we'll improve on that as well. So the sensor, if you notice, it's trying to make the data available, and then it's going to send it over to Arduino, which is going to send the same data over to USB serial. Now, I've used just one sensor, but there may be many more, and we'll see. Vic is going to grind a lot of sensor data together today. And then finally, it's going to send it over to the gateway, which is our Node app. And the Node app is going to take that data and send it over to the cloud using a simple HTTP post. So the architecture, once again, is like this. Graphically or visually, there are various sensors. The one that I'm using is just one today, DHT11. There is an Arduino in the middle, and then there is this node gateway running on my machine. And then you can send it over to the cloud. And the beauty of this gateway and nodes ecosystem is that while today it's on PC, I can actually run the same node code on another small IoT device or Raspberry, and that should just do it. So let me go there. Let me bring the Node application that I have written so that you know what it does. You don't have to know Node. It's just to show you how simple this can be. Um, Here. So I will drag this in. Uh, Pretty much this is the code for it. Not too long. It's pretty simple. There is a serial port, which is the serial port is COM4. I'm reading at baud rate 9600. And then what I'm doing is I'm opening that port, which is ready to listen. And then I'm going to run this. And each time there is a data that is received, which is here, simple JavaScript, you will actually be parsing that data. So all this is, parsing of that data. And after that, I'm just going to send it over to a website called ThingsSpeak, which is a simple gateway for uploading data. And I'm going to send my temperature and humidity data over. Simple, and you know my code. So what I'm going to do is now I'm going to run this code quickly. And to run this, I should have to go into the command line. That's how you trigger them. I have it running in my node projects. There is Arduino temperature. Let me see. So what I've done is I have simply this, and I'm going to run it in Node right now. Node temp server.js. Well, so what it's now going to happen is the node application is going to initialize itself. Sorry, it's going to take a second. Okay, now it's ready to listen. And every 15 seconds, it's going to listen to the data that is coming in, show you that data, and actually send that data over to API that we talked about, which is the things speak. Okay. As you can see, it recorded a humidity of 65, temperature 27, and it made making a temperature request. It sent over 27, which is the temperature, and it recorded a response of 245, which is the cloud specific or the application specific response. Now, why don't I actually get you to the Things Speak website as well? So let me go there. And in the meantime, you can notice since the node is continuously listening, it will keep listening and keep getting this data in. And I have my digital thermometer now, which is reporting data in the on the website. So watch this. It is actually getting plotted right here. And as you can see, both the temperature and the humidity are being shown in a graph format. So you will notice the data, there are about 46 entries, some from the past. And the numbers that you're seeing now, 45, 46, 47, 48, these are the numbers that are the latest numbers or the ID of that entry made. Now, these entries are being made, as you can see, the last one was made less than a minute ago. Now, this is you can actually go and watch this yourself, but to do that, I will have to do a small change, which is enable this to be a public channel so that you can actually browse to it. So it's not at this time. I don't think we have to do that. But notice all the data that is coming in. You can actually view all this data that is coming in. It's a simple format. All that data that you're seeing, notice at the bottom now, this is the one that is coming in. It is getting the date, it is getting the entry, and it is getting the field, which is 27 is the temperature, and 65 is the humidity at this time. So now we have the sensor that has put out the data, and we have uh, the uh, the node which was running on my machine to actually run this and upload the data on the cloud. So that was my digital thermometer. And this was not the best way to go about it because there's still the PC involved. And now to actually show you an even more realistic view of how the world works with all the sensors and the real IoT from end to end. We have Vic. I introduced him in the beginning. So I will now make him the presenter. So give it a second as he starts to set up his system. And Vic, it's over to you now. You can show them the great stuff.
Screen. Abhishek, can you see my
It
screen?
is still not come up, so give it a second. All right, now it's
All right.
visible.
All right. Which screen are you seeing with the one with the camera? Yeah, okay. So let me do this. So I'm keeping my camera on the side so that you can see that all the time. My demo today is more towards how do we take the data, how do we use an Intel Edison board. So what I have here, you can see, I have an Intel Edison board. It's kind of little bright here, but you can see it's a beautiful Intel Edison board. What I've done here is I've connected an LCD. Even this is fairly bright. I think I have to blame my camera for that. Um, I tried to connect my Canon on that, but the drivers are missing and all that. So please pardon me for that one. I've connected quite a lot of things here. So I've connected a pot here, I've connected a buzzer here, I've connected a temperature sensor here, I've connected an LED so that we can see some feedback immediately also. I've connected a button, I've connected a touch sensor, I've connected a relay, I've connected a mic, I've connected a light sensor. I've connected quite a lot of things. I still have a lot of other stuff to connect, but for the demo, I think these many things are good enough to start with. So very first thing is the Edison board. If I introduce you to the Edison board itself, it's a very simple board. It has a power supply here, so you have to give it a 12-volt power supply. And over here you can see there are two connectors. One connector is for the USB and the other one is for the serial. So you connect the USB to your computer the way I have connected it here. Let me kind of show you that. So there you go. I have connected that guy here. Okay, and this one is for the webcam. So the other connector here, the red one, is basically going down to the serial. So if you want a serial communication, you can connect the other one also. But I don't need the serial communication. I am displaying everything on the LCD, so I don't really need to see anything on the net. Sorry, on the laptop. So what I'm doing is I'm taking all this data data from my pot. So if I change the value of my pot, that will go to the net. My temperature sensor, my button, my touch sensor. I have an LDR here. Basically, it's a light sensor. I also have a mic here to detect how much noise is there. So now that I have started speaking in this event, the noise level of this room would have automatically increased. So let me show you how I'm doing all these things. So here is my ThinkSpeak. So let me just go ahead and reload this guy. All right, so here you go. So you can see here the noise has significantly increased, and on the LCD, LCD is not showing anything. That means it is not sending any data right now. Okay, so now it's sending data. I'm sure you guys are not able to see my LCD, but so here LCD shows waiting right now, and it will go from waiting to sending data and the data sent. I'm sorry, I could not really show you that very clearly. I tried to change the contrast value of the LCD also, but still it doesn't show. So pardon me for that. But the interesting thing is here you can see I just messed with the pot. So the pot value has changed. Let me go ahead and change it again. In fact, let me do it side by side. So all right, you guys can see my entire screen, right? All right. So here you can see here the pot value. Okay, and let me go ahead and change it. So I'm changing it quite drastically. So you can see the next data that will come here will change. Let me also try to hide my my LDR, basically the light sensor with some kind of a cover, so the light reduces, and let's see how that goes. So you would see in a second. Basically, ThinkSpeak does not allow you to upload data more than every 15 seconds, sorry, less than every 15 seconds. So I'm just waiting for every 15 seconds data to be populated. So that was 1306, and I think I should get some new data sent. I will show you how the coding and all that was done. All right, sending. So it has sent from here. Let me see if it refreshes down here. Let me try to reload this guy. Oh, there you go. So I think it was more of a refresh issue. So here you can see that the change of the pot value has decreased here. Also, you can see the light has decreased quite drastically. Let me remove the hiding thingy on this. Let me see if I can put some light on this. I'm using my phone to just put a flashlight, just for the heck of it. So you would see that the noise level has increased quite drastically since I'm talking, since my session has started. The light has decreased quite down. Now it should come with an increased light as soon as I have the updated charts here. Let me try to reload this guy. And the interesting thing is here you can see my temperature. So I'm plotting, okay, you can see here the light has increased, right? Let me turn down my flashlight. All right, so you can see the light increase, and of course it's going to go back to the normal levels that were there. The data that is shown here is from yesterday night. All these data. So if you see here, this is July 23rd, 12:47. So let me show you a couple of more things. So let me, instead of showing last 60 result, let me show last 10,000 result and give you an average for every 20. And yeah, that's it. So let me see how that goes. So you can see here the light was, sorry, the temperature was high at yesterday 21, and then it went down to 26 and then came down because I started the AC in the morning when I came to the office. So it is now 22.5. So the current temperature in my office is 22.5. The pot value, I changed it. So pot value, I put it in such a way, I mean, the reason of putting a pot is just to have some kind of a sensor sending some data to this server. The amount of light in my room is somewhere here at this point of time. The noise level is this much. If I touch the touch sensor, so if I hold the touch sensor, since it is every 15 seconds, you can see my light turned on. So I have married the touch sensor to the light, but then the interesting thing is you can see that thing happening on here. So the touch was always 0, now it can show 1, and the same thing goes with the button. So if I press the button, and let me press the touch also together, who the hell cares? So let me do that together. So I've touched the button and the touch sensor together. So you can see the touch sensor gave you a double reading and the button gave you a single reading. So all this data is live on the net, and let me show you how this thing is done. And so I wanted to show you this first, and then go back to show you how to wire these things up and all that. Okay, so let me jump to the Arduino IDE, and so here is my code. Let me show you one simple code first. So let me open one of the sketches. Let me show you one of the test sketches that I created. So here is a very simple test sketch. Here it says that the button is connected on digital 3. So if you see, here is my button, and there is the D3 on the board. So if you see somewhere there, you can see the D3 connected. So the button is basically connected there, and I have named another integer as a touch. So basically my touch sensor is connected on the 2. So if you look at that, it shows D2 down there. So those are two digital ins, and what I'm doing is I'm having the LED connected on 7. So if you see, that's the LED, and the LED is basically connected down here on the 7 number. So let's do one thing. Let us upload the sketch and first upload that, see it running, and then try to understand how the thing works. So I'm just uploading the sketch, and I hope everything goes all right. So when it says transfer complete, it would have done the job. So if I technically press the button, it will go ahead and turn the LED on. It's as simple as that. And if I take the touch sensor and if I touch it, you can see that the LED is turning on. So it's the same thing. You do anything locally, or if you want to send the information down to the cloud, you can go ahead and do that. So how you do it locally is very simple. As Abhishek was saying, you set up your pin modes to be inputs, and outputs. So my LED is an out, button and touch is an in. You run through the loop. I am taking the button state, so I'm taking a state of the button and the state of the touch. I'm doing a digital read in the entire loop every time the button is pressed or the touch is touched. If the button state is 1, which is basically the high, what I'm doing is I'm simply saying LED 1. 1 is again high. You can write high, you can write 1, anything is fine. So if your button state goes 1, you are doing an LED high. If or else if the button state is 0, you set it back to 0, basically turning the LED off. And the same thing with the touch also. So if somebody has touched it, it becomes high. If it is high, go ahead and set the LED high, else go ahead and set the LED to low. That's as simple as that. So if you do this, that's the effect. So press the button and there you go. So it's as simple as that. So let me show you another example. So let me show you, let's say, a relay. So relay is interesting. So what I'm doing is I have a button pin 3. Let me make sure that is on 3. So yeah, it is on 3. The relay pin is on 6. So let me check my relay. Relay goes to 6. That is also correct. So yeah, it's the same stuff. So I'm getting the button state. If the button state is 1, digital write relay as low, or else digital write relay as high. So it's the same thing. Instead of LED, it's a relay. The relay can drive the lights in your house, or it can drive the AC in your house, or anything. So technically, if you want, so for example, if you want to change anything to a touch, just move it to whatever the touch sensor number is. So let me go ahead and run this guy. You all right, so that got almost uploaded and uploaded and uploaded. Okay, beautiful. So what we have here is we have a relay. All right, and you might be able to hear the sound on the relay also. So let me press the button. So you can see, at least you can see the light. Maybe you cannot hear the noise, but you can see that every time I press the button, the relay goes on. Now you can make the button as a toggle button. So all you have to do is write a little bit more code and put a flag condition. So if you press it one time, the relay will be on. Press it another time, the relay will be off. Some logic like that. In fact, you can control the relay from the cloud. So you can get the data from the cloud, since this is connected on HTTP. I will show you that code also, and you can control the relay. You can control basically anything out of these, directly from the cloud. So I hope you understood the basics of it. So let me go to the real thing. So here is the one that sends the data to the cloud. Okay. What we are doing here is we are doing wire.h. Basically, it's a one-wire protocol. So we are including the wire, we are including the LCD, so that I can see the information on the LCD. Most of the time, this guy is not even connected to my laptop. It is connected directly to the power supply. So when I go home, I just disconnect my laptop's connector and I just let it be, and it keeps sending data to the cloud. Yeah, so if we have an SPI. The SPI is basically to get the LCD working, because the LCD works on the SPI interface, and the Wi-Fi.h is for the for connecting the Edison to the Wi-Fi. Now we have some Wi-Fi information here. I am creating a server connection here using thingspeak.com. What I'm doing is I'm creating an instance of a client. Now a client is the most important thing that we are using here. So let me show you this guy. So how this thing works is I have set up the button, I have set up the touch, I have set up the LED, I have set up the temperature. So basically I have set up the entire thing. Then I'm doing a setup here which says the inputs and outputs and all that. I'm doing a serial.begin with a baud rate of 1152. So that is the fastest it can go, and obviously I need the fast baud rate. So I'm doing an LCD begin. So if you do LCD begin, you are mentioning that it's a 16 character LCD with a 2-line, and you do an RGB. So you basically set the color of the background. So right now it is some cyan color. If you want it red, so it becomes 255 and let's say 0 and 0. So that will make it red, and I'm sure you can see red color maybe through the camera. I'm delaying it 10 just to delay the process of setting the RGB. I'm doing a Wi-Fi begin with an SSID and a password which I have set up on the top. I'm doing some serial connecting just in case if I want to see that on the serial. So it will show me connecting to, and then it will show me the SSID which is connecting. After that, I'm going to set up. So I'm doing the connecting to 2 times, so that I get some more clarity on the connecting, because many times when you run the program and then when you run the serial, by the time you run the serial, the first thing is gone. So that's why I've set up a delay also, and that's why I've done connecting to, so that I can see which Wi-Fi it is connecting to. I'm doing some LCD begin, LCD clear. I'm setting this cursor to the LCD. I'm creating some information on the LCD that shows the Wi-Fi connection and all that. If the Wi-Fi is connected, I'm showing connected to the Wi-Fi. And then the main thing is the loop. So that is the setup part where we are setting up everything for the board. In the loop, what we are doing here is, first thing I'm doing is I'm doing an LCD clear, because the LCD is already pre-populated with the connected Wi-Fi connecting and all that thing. I'm just making it clear so that we can write new data to it. Then I'm collecting data, so I'm doing a pot sensor, light sensor, noise sensor, and I'm doing a temperature. Sorry, I would have given a proper name for that. Then I'm doing a button state, touch state, all of that I'm collecting. So after collecting all of that in the loop, what I'm doing is I'm doing a client.connect. So client is basically the Wi-Fi object. So if you see down here, we are creating the Wi-Fi object. Where did that go? All right, it should be here. So Wi-Fi client is the client, right? So from the Wi-Fi client, what I'm doing is I am creating, so there you go, so client.connect, and the server is the server URL, and 80 is basically the port on which we are connecting. So the moment we connect, I am saying sending data, because that is the time when it is going to send the data. I'm creating a string for doing a post request, and then I'm creating field 1, field 2, field 3, field 4, field 5, field 6, and it is going to send in all the all the 6 fields: temperature, light sensor, noise sensor, pot sensor, touch state, button state, all of those things into a single post string, and then I'm doing /n for the new line characters to end the thing. So I'm creating a post string. I'm sending a post string here. I have to set up some headers as per the ThingSpeak API. So I'm setting all of that. So after doing all that, I'm doing a post. So that guy is going to do the post right there. So the moment it is done with the post, what I'm doing is I'm doing some serial print and some LCD prints. If my button state is high or my touch state is high, I'm doing the LED so that I get an immediate feedback on my LED also here while it is doing the thing. This is also for me to debug whether the thing is really connected or not. Because here, if it is not connected, then my LED won't turn on. So that is one simple way for me to check whether the data is done. Whether the data is been sent. Also, I'm doing an LCD print info send. So on the LCD, you would see waiting, and then it will switch over to the info send and sending data and all that. So that's how it is. The simple thing is after the if condition of the connect, you should stop it. Since ThingSpeak needs a minimum 15 seconds delay, what I'm doing is I'm doing a delay of almost 1,000, and then I'm doing an LCD clear and doing an LCD print waiting. Now, if I don't do the delay here, what happens is it keeps showing waiting. It does not show the info sent because the time it takes to upload that much of data is extremely small. So it doesn't take so much time to upload the data, and by the time it goes to info send and waiting, it just is too fast for anybody to see that. So what I've done is I've split the 20-second delay into delay 1,000 and delay 19 here, and then I'm doing an LCD waiting. So most of the time on the LCD you will see waiting only for like a fraction of a second. You will see info send and connecting and all that. So that's how the whole code is done. So that's how the code is. Let me go ahead and upload this code. The only change I believe we have done is change the LCD RGB value. So from the cyan color, most probably that thing will switch over to a red color. And then you would see the fluctuation happening on the net. So here you would see the fluctuation happening also. So right now it is still on the waiting state, and the LCD goes red, and in some time it should start to show connecting to Wi-Fi. Well, I'm sorry I have to speak this out, but I hope you guys could have seen this one. It's kind of interesting. Let me see if I can mess with this guy. So, not really. No. So yeah. So You cannot see that. It shows waiting right now. That means that it is connected. After it is connected, it should be sending data. So we can see the data coming in down here. Let me refresh this guy. Okay, so you said it's updated less than a minute ago, so I'm sure. So by the time we were messing it up, you can see that there is a lag here, and that lag is the live lag. So the light is now 540. The pot is at a state. You can let me change the pot value to something else, and you can see here all the lags are showing up. The noise level has reduced. Maybe I started speaking a little low. So yeah, that's the thing. So that's a simple way of showing you how this thing works. I hope you guys liked it. I'm sure we are burning a little too much time, but if you guys have any question, please go ahead and ask at this point of time. Thank you.
So thank you so much, Vic, for showing this awesome demo. Um, So for questions for Vic can actually be entered now if you have any. And for the rest of you, thank you so much for being here. I know we've extended it. We were just so excited about what we could share today that we just went overboard. But thank you so much for being patient with us. We have